Okay, so we have one more definition of acids and bases. Here's Teddy, he's going to help. And we call it like the alternative definition. If you listen to like alternative music or alternate, it's kind of like different. So this is like the different definition. So somebody said, hey, you know what? NH3 doesn't end in OH, but it very much acts like a base. So we need like a definition that includes things like that. Because NH3 is ammonia, and that's definitely a base. So we needed like this broader definition that included things that don't like donate OH negative ions. So we made a broader definition. We call it the alternate definition. And you kind of think of alternative things like being more inclusive. So it includes more things. So here it is. It is called Bronsted-Lowry. You don't need to know that. But that's who came up with the definition. So it says acids are anything that donate a proton or H+. So that's really the same as our last definition. So acids really aren't changing under this alternate definition. I think instead of saying releases H+, they say donates H+. So really the same thing. What is going to be a little bit different is our base definition. So the base definition right here says, you know what? You could be like NH3. You don't need to have an OH to donate. All you have to be able to do is kind of act as the opposite of an acid. If acids donate H pluses, you just have to be able to receive an H plus. And in that way, you're kind of like acting the opposite of an acid, and you are acting like a base. Okay, so this is our big difference. Under the alternative definition of acids and bases, acids donate instead of release, just a little bit different wording. They donate an H plus. Bases, instead of releasing that OH negative, we're going to say, yeah, they might have an OH, but they don't have to have that OH. They could be like NH3. All they have to be able to do is receive an H+. So in kind of acting the opposite of an acid. And remember, if you're going to say, okay, an acid donates H+, also known as hydronium, also known as H3O+. So remember those synonyms, unfortunately. The Bronsted-Lowry base definition. So because it is a little broader and it's like you don't have to have an OH, you just have to be able to accept an H, it includes more things. Like it includes NH3 as a base, which is good because NH3 does act like a base. It's so broad that it could even include water. In certain reactions, water could act like a base, which is weird because water is neutral. But here's how you can tell if something's a base from a reaction. I could look at this reaction and say, okay, well, what is NH3 doing? Because I know if you give away H's, you are an acid. If you're good at receiving the H's, you're a base. So let me look at what NH3 does. So NH3 got together with water, and then after, it became NH4. So if NH3 became NH4, what did it do? Well, it looks like it received an H. It went from NH3 to NH4. So it gained an H. So what is it? It received an H. It is a base. It's doing base stuff. NH3 in different circumstances can also act like an acid. So we're going to call it, just like if you can write with both hands or play baseball with both hands, you're ambidextrous. If NH3 can act like an acid or a base in different reactions, we're going to call it kind of amphiprotic. Let's try one more practice. So let's look at this reaction. Let's figure out who's the acid here and who's the base. So you're going to look at what they did from where they started to what they became. So I'm going to look at HNO3. I mean, I kind of think it's an acid because it has an H out in front, but let me look at what it became. HNO3 must have become NO3. So it looks like it lost an H, and that's what acids are really good at. They're good at giving away H's. So actually, the worse you hold on to your H, the stronger the acid you are, because you're like really good at giving away H's. So this must be my acid because it gave away an H. Now, what is this? Okay, so it was H2O. It didn't become NO3. It must have become H3O. So if it was H2O and it became H3O, it must have gained an H, and that's what bases do. So here, the water is the base. So actually, under this definition, even water in certain circumstances can act like a base. So let's just sum up. Acids, really under both definitions, different words, donate, lose, give away, release is the other word. They're just really good at giving away H pluses. But remember, those could also be called H3O plus or hydronium ion. They have that pH less than 7. The stronger they are, the lower, and those acids can burn you. Bases, our first Arrhenius definition says that bases donate that OH. That's why most of them end in OH, also known as hydroxide. Okay, so you got to know base donates OH or hydroxide. But under the less strict alternate definition, they could also say, okay, well, you don't have to have an OH, but you at least have to be able to accept or receive an H+, also known as H3O+, also known as hydronium. pH greater than 7, the stronger they are, the higher the pH, and they can also burn you.